Hello, everyone, and welcome to Klara's 2024 webinar, where we will answer questions about ZFS. So first, I'd like to introduce our host, Jim Salter. You want to take a minute and introduce yourself?
Hi, everybody. I'm Jim Salter. If you've been in the ZFS space for a while, you've probably encountered my tools Sanoid and Syncoid in the wild, and maybe even heard me go on at length about ZFS on 2.5 admins or at any of various open source conferences. Of course, with me today are Allan Jude, who is co-author of ZFS Mastery, along with Michael Lucas, among many other things. And Klara is, of course, Allan's company. And we also have Mark Maybee. Mark, how about introduce yourself to everybody?
Hi, thanks. So my name is Mark Maybee. I was one of the early developers on the ZFS. I worked with Matt Ahrens and Jeff Bonwick and others to develop ZFS way back in the days at Sun Microsystems. And I've pretty much been involved with ZFS development since then. So over the course of however many years it's been since we released ZFS in the wild.
Yeah, I guess open source is coming up on 20 years soon.
I think so, and that was, that was when we opened it, made it open. So I mean, the development in ZFS actually started, I'd say around 2020 is when we really started doing active development on ZFS. So it's been close to 25 years. Sorry, yes, 2000.
Yeah.
22000. Anyway.
Yeah, it's been a good while.
Yeah,
I think it's been 16 years since FreeBSD first got its own port with 7.0 release, which is when I began using ZFS.
Yeah.
It was 2008, right, Allan?
That sounds right. Yeah, because open source was 2006-ish.
Yeah, it sounds right.
Halloween 2006. Yeah, so
yeah, Halloween was always a special day for ZFS because we always tried to release some new. The original release was around Halloween. We always try to release on a Halloween to make things interesting.
The timing worked out really great for me personally because I became aware of Bonwick's blogs about his own adventures and misadventures that got me I was gagging for it. I had to have the file system that he talked about having horribly failed to administer, a simple RAID mirror and had tens of thousands of errors and never saw a problem from it. I read that blog post and I was like, I don't care how much slower it makes things, which of course it turns out it didn't make things any slower, but I was assuming this would be a huge performance hog. And I was like, I still have to have this. And I had like just enough time to get, really excited about all this stuff that I saw Bonwick blogging about. And then like a month or two after I started getting excited, bam, it drops in, FreeBSD 7.0 release. And I'm like, yes, I can has.
Yeah. Yeah, it was in the early days when we first released it to the open world. We worked closely with a number of developers to try to get it ported into various environments as quickly as possible, and that was largely driven by just enthusiasm like yours out there, where people were like, "This looks really cool. I really want to have it on Linux. I really want to have it on FreeBSD. I really want to have it on Mac OS." And so these efforts started up almost immediately as soon as it went to the open.
Well, shall we get started with the actual questions that folks have asked?
Yeah, and remember, the audience, please do submit your questions live, and we will try to answer some of those.
Yep, I am monitoring the chat, so as things come in, I will see them pop up. All right, from the ones we've already got that people sent in ahead of time, we'll start with, do you recommend ZFS built-in encryption or running ZFS on top of another encryption mechanism? I heard recently there's been some bugs around sending encrypted snapshots between ZFS pools.
I'll take a first comment there. Encryption is, one of these things where it depends on your use case, right? It depends what your needs are with encryption. If your need for encryption is simply I have a requirement that my data at rest is encrypted, then utilizing something like encrypted drives makes a lot of sense, right? It takes away any of the the need for the file system to understand anything about what's going on or the encryption, and maintains your data in an encrypted format so that if someone steals your drive, they can't get at your data. On the other hand, if your needs are more varied or more fine-grained, you need to be able to encrypt, for example, different file systems with different keys to manage your data, because you don't want other people to see your data whether you're working in the same organization or what have you. There you're going to need something like ZFS encryption to give you that ability to get that kind of granularity. But it comes at a cost, of course, of additional processing and the key management problem, which is something you just have to deal with, and that makes life a little more difficult, but you get that flexibility.
Yeah, kind of building on what Mark said, if your main concern is just, I need to be able to return this drive to the manufacturer if it fails without there maybe being data on it, then either encrypted hard drives or whole disk encryption like Galley on FreeBSD or Lux on Linux can make a lot of sense there, and that will solve your requirement and means you don't have any of this extra complexity. But to Mark's point, an example that we've helped with at Klara was a lawyer's office who needed to encrypt different cases with different keys, not so much because they required the encryption, but they had to be able to prove that once the case was over, that they destroyed their copy of like discovery evidence. And if they use something like Geli, they'd have to destroy the whole pool and like recreate it and recopy all the data that they do need to keep. And that doesn't make sense. Whereas with ZFS, they can have different encryption keys for different cases. And then when a case is over and they need to destroy the data, they just destroy the key. And now they've destroyed the data set, but they have a provable way that they can't get that data back. And especially now with disks, especially like SSDs and NVMe, you never know, just because you erase some data, or even if you overwrite it, you don't know that that's the data that actually got overwritten.
Right.
And,
Yeah, exactly. Reliable data destruction is a very important use case for encryption.
Yeah, and being able to do that more selectively because of the way ZFS lets you break your pool up into those data sets so that you can control them separately.
Yep.
That makes a big difference.
Yep.
And the other one is also just, as Mark mentioned, encryption only works when data is at rest. And so that is basically when the encryption key is unloaded, then the data is safe from being read. But if you're using Geli or Lux or whatever, as soon as the pool is imported and you have that encrypted volume open, all the data is available decrypted. That's how it works. And so being able to, again, by using ZFS and having the separate data sets, you can take a chunk of data and decide, I'm going to unmount that and unload the key, and I'm still going to be able to do scrub and resilver and replace failed drives, and all my maintenance operations will still work. But I know that nobody can read that data until they load the key again.
All right.
So when we helped a medical company build their certificate authority system, being able to have certain private keys offline, except for the one time a month when they needed them, or only when they were approving new hardware, it allowed them to have a lot more safety from the encryption than they would have got with just regular whole disk encryption.
Okay, but so far we've talked about all the things that are great about using ZFS encryption. I haven't heard a whole lot addressing the second half of that question, which was about having heard about bugs sending encrypted snapshots between pools. So can we speak a little about, how prevalent those bugs are and what's likely to trigger them?
So far, we've only seen it once on an ongoing basis, but it was with an older version of ZFS, and we found that it was already fixed in the 2.2 version of ZFS. We've seen few reports of it that have any detail about what was happening to be able to look in it. So the ZFS community is very interested in fixing these bugs, but oftentimes the bug reports we get don't have enough information to try to actually solve what the problem was.
Yeah, and so in my experience, bugs do happen. I think with encryption, those bugs tend to be more painful when they do happen, just because you are often losing data in an encrypted environment when you encounter a bug like some kind of bug. But I don't think that they're particularly prevalent, and I don't think that we've seen a lot of them. Certainly over the years that I've worked on ZFS, we have found and addressed a number of bugs in that kind of space, and we're always eager to address any bugs that do show up. So as Alan said, if we have the data to be able to hunt it down and squash it, we will.
So to
Yeah,
be
and to be
accurate to
clear
say
that
that right now, as far as we know, there are no current bugs that are likely to get hit with currently released versions of OpenZFS and encrypted replication.
I am not aware of any existing bugs out there. Someone may be able to correct me, but I'm not aware of anything that's open right now, but there might be.
Okay.
Alan, do you know anything
there's
off the top?
basically we've seen some reports of issues, but there's no known issue.
Yeah.
And to be clear, the one that we saw with a customer was not losing any data. It was just causing ZFS to panic and have to reboot, and then it would work fine after. So there was no actual data loss. It was just crashing ZFS, which is a problem and got fixed. But we definitely, if you are seeing this problem in ZFS, we'd love to get more detail about what's happening and more than just, hey, I tried to replicate something and it crashed. We need details and backtraces, and ideally, if you could make it happen with data, you'd be happy to share a very small send stream that causes the problem. It'd be much easier to track down if we had a reliable reproduction case.
Okay, great. So moving on, just one more tiny bit from there, and then we can be done and move on to the next question, I promise. So since we've established that as far as we know, all the outstanding bugs involving encrypted replication have been fixed, you may still hit one, but it doesn't seem particularly likely. Now, moving on from that, what would be the best practices that we would recommend to make sure that somebody who might possibly get hit by this kind of bug not like suffer unduly from it? For example, would we always recommend to have one unencrypted backup in case of this type of issue?
Unencrypted might be pushing it, but
Yeah, about to say that's a hard thing because usually you're encrypting for a reason. Now, if you are encrypting just because you're transferring information from one point to another, and it's the reason for the encryption is to keep it secure while it's in transit, then yeah, keeping it, having your data unencrypted someplace locally that is still secure might be is probably a very reasonable thing. But usually, you're using encryption, you're employing encryption because you have the need to have this data encrypted, and having it unencrypted to prevent data loss for whatever reason is probably not going to solve, be within your solution space. Like, well, that's sort of destroys the whole reason for encrypting this data in the first place.
Or maybe just splitting the difference and having, basically when I was saying unencrypted, I didn't necessarily mean the data itself unencrypted at rest. I just meant not ZFS encrypted. For example, you might have one backup target be Gelly or Luke's encrypted pool. So your data is still encrypted at rest there, but a ZFS specific encryption bug isn't going to take you out everywhere.
Yeah. All right. That would probably be reasonable.
Yeah, that would be a reasonable way to add some extra surety, and it also protects you a bit on the key management side as well. If somehow you lose the key that encrypts that data, you have a different copy of the data encrypted with Gelly or Lux. That's a different key that hopefully you have behind a break glass system somewhere to manage that.
And the last thing that I will say, I will add my own recommendation for best practice here, which is that this kind of bug shouldn't be too terrifying because you should be monitoring your pools anyway, both your production and the backups that you have. You should be doing automated monitoring. Your automated monitoring should tell you, is the pool healthy? Has it been scrubbed? Are there any checksum errors? Have there been any IO errors? And what is the most current snapshot, that's present in each of the data sets that I care about on this pool, which will tell you, is my replication working? Is my pool in good health? All these things that you're worried about. Now, if you've got automated monitoring that's keeping you up to date on this stuff, then if you do encounter one of these infrequent bugs and you do have replication not work, or even an entire pool become unmountable, you catch it immediately and you can actually resolve it. Where you really get screwed on this kind of thing is when you're not monitoring your systems and you have errors accumulate behind your back and you don't know about it until it's a catastrophe.
Right. And insufficient backups.
All right. Moving on to our next question. Generally speaking, what's the preferred type of solid-state device for the ZFS intent log for a log VDEV, and for the and for a cache VDEV, aka the L2 ARC? And do you have any favorites if you're rolling your own appliance?
So I don't roll my own appliances, but you know, essentially whatever the lowest latency you can get on these devices, where you have a device, you know, in the I/O pipeline, where you are depending on this device to actually be part of the experienced I/O path from the end user's perspective. You want to have the lowest latency possible on that device. So for a logging device, obviously, if you're logging and you're doing a synchronous I/O, that means that write has to get to the device and returned before you can respond back to the user saying write complete. So obviously, you know, that is a specific cost you'll pay with every I/O, synchronous I/O that you're going to do. So having a very high or very low latency device there is critical to achieving the lowest possible latency at the user application end of the pipeline. The same is going to be largely true for L2 ARC devices, because that's a similar thing where your read, this is in the read path, but you are using that to service your read. So if you want to service it faster than your backend disk can service, you need to have something with latency that's going to be lower than your backend device. Otherwise, what's the point of putting that in that device in the path? So, you know, specific devices, you know, NVMe drives are common in these kinds of applications. Allan, you probably have a lot more experience in various customer use cases that use different devices.
I'm actually going to jump in real quick before I turn this over to Allan, because of that last note about NVMe devices being very common. Please do not assume that just because a drive is NVMe that it's a good selection for a cache VDEV or a log VDEV. In fact, the majority of the NVMe drives that I see out there on the market are a terrible choice for either selection, because most of the NVMe drives out there are consumer targeted. Most of the kind that people who are new to this space and need this kind of talk are looking at are on the lower price end, because there's not a lot of understanding about why one drive might be more or less expensive than another. So when Mark was talking about the importance of low latency, what this means is that the drive has to be able to get the data that you sent to it committed as rapidly as possible, so that it can tell the operating system, okay, I synced that right like you asked me to. That's the whole point, is you're reducing the latency of that operation, because when you do a sync write, that thread can't do anything else until your file system says, yes, I've committed that solidly now. It's not it's not volatile anymore. It is on non-volatile storage. That's the entire purpose of the ZFS intent log, is just to get that data non-volatile as rapidly as possible to reduce that latency. Now, a consumer NVMe drive is not latency focused. It's going to be tuned for the highest throughput on the easiest possible workloads, because when the reviewers just do one quick, simple, let me see how fast I can read or write data from this drive, they're going to say, this drive had the biggest number when I did this one thing, and therefore it's the one you should get. And it's what everybody winds up with. However, when you tune for really high throughput on really easy workloads, you are also tuning for abysmal latency on the really nasty, difficult workloads, which is exactly what a log VDEV is. So
yeah, I think.
Now, Allan, you want to go? I had to get that in quick before people process the NVMe
yeah,
for
no,
too long.
That's good correction. Like I said, I don't roll my own, so I work in high-end environments where that's, you know, things are looked at, and it's a different class of drive that they're looking at there, certainly.
Yeah, so kind of to build on Jim's point, definitely want to avoid QLC, so that's quad level cells, because generally those devices will have a small amount of really fast storage to make the reviewer thing, like a benchmark, look good for a couple of minutes, but if you run it long term, it will run out of that. And just in general, you need basically a high endurance device, and you want, you know, fewer levels of cell packing, because you're going to get more endurance and more performance, more sustained performance from that. the other big thing is while the log device does not need to be very big at all, like your log device is only holding a little bit of data temporarily, so it doesn't need to be big. On the endurance front, generally, the bigger a drive is, the more endurance it has. So oftentimes you end up with a large drive that you're mostly underutilizing. But yeah, the endurance is the big thing there because you don't want that device to wear out. Although in general, most devices will be able to handle most of what your pool can throw at it. But the log device is a bit special. It's doing a lot of lifting. Like if you're running databases or other things off of it that are doing, thousands of sync writes a second, you definitely need to be able to deal with that in this log device. Yeah, and kind of to that point, you also have to think about cooling. A lot of these NVMe drives have thermal throttling. When they get too hot, they will slow down. And so it will work fine in your testing. And then when it gets in production and runs hot for a couple of days, suddenly the performance goes down. And so the cooling for it and just the form factor could be a big difference. And that's why things like, U.2 and U.3 type drives and things that are, designed to keep it cool can make a big difference on the quality and the lifetime of the NVMe drive.
Yeah, so write endurance was the other metric I was really looking for. Thanks for that, Allan. That does wind up being very important. If you're building a system, excuse me, if you're building a system that actually needs a log vdev because you have a very sync write heavy workload, for example, let's say you're building a bulk storage server and all of your clients are going to access this server over NFS. Well, that means that your entire workload is going to be synchronous. Every single write will be a sync write. And you can put a log vdev in front of an extremely large pool that sees a whole lot of traffic. But the thing that you need to remember is those writes that are divvied up amongst, let's say, 20 terabyte spinning Rust drives, they're all getting filtered through that one little SSD or pair of SSDs or whatever that you've got configured as a log vdev because all of your writes are sync writes. So you can run through the write endurance a lot more quickly than you would imagine if you're on a very write heavy workload to begin with. Now, the other thing, as far as specific devices go, there's one thing I was listening for that I did not hear, and I'm a little disappointed. I will forgive not mentioning Optane because it's almost impossible to get 3D X-Point technology anymore. If you can find it, Optane is the ideal storage mechanism for a log vdev specifically because although it's not very high throughput, it is UFO class low latency and UFO class write endurance. They're essentially impossible to kill. So if you can find Optane, that's great. However, that's not the thing I was upset about. Like I said, you kind of can't find Optane anymore. The other thing that you should look for if performance is really important to you is you want power loss protection on the solid state drives that you're using for your log vdev. And the reason that you want that is because the power loss protection on the drive means the drive can immediately return that sync call even before the data is committed directly to the physical media on the drive, because that power loss protection supercap is making sure that the cache memory on the drive is effectively non-volatile, because if you lose power, then the supercap powers the firmware for long enough to get those dirty writes committed down to the metal on the drive. So if you've got power loss protection on a log vdev, it can return those sync calls drastically faster than even a very fast SSD that doesn't have power loss protection, because that one will have to wait until the writes are actually committed all the way down to the NAND flash.
And that's if it does the right thing and doesn't just lie and say the write finish when it hadn't.
Right, which I've experienced in the past, where a drive will claim it's actually power loss protected, but yeah, that isn't.
That goes both ways, though, and that's another reason for being, really skeptical about this consumer stuff, because consumer gear in particular has been witnessed many, many, many times ignoring write barriers and not even pretending that it has power loss protection to make it okay, just ignoring them because that makes number go up.
Yeah.
Yeah, and that's where Klara's solution, where we call it ZFS design and implementation, really comes in. If you're building something that's going to be mission critical for you, you should reach out and we can help you pick the right hardware for your workload, because what is the right SSD is going to be different based on, are you hosting VMs? Are you doing NFS? Are you doing video editing? What are you doing with this, and what's the right layout? And, do you want an L2 ARC, or is it not going to help you? And do you need metadata vDevs? And how do you make enough redundancy in your metadata vDevs? And on and on. There's so many questions to answer to actually build the pool that's right for that workload.
And yeah, there really is no one correct answer to any of the stuff that Allan was just talking about. The great thing about ZFS is that you can tune it very specifically to your exact workload, and that can make an enormous difference in how well your systems function. The drawback is there's a whole lot of knobs that you can twiddle, and you can
Yeah,
get overwhelmed looking at them.
I about to say that's a great thing and it's not so great thing sometimes. So
Yeah.
Yeah,
All
it'll
right,
work
so-
for everyone out of the box, but you can make it work a lot better with
Right.
some help.
right. And so the tuning, in fact, are designed to be, general workload sort of specific, but yeah, it's you always can tune for your specific workloads.
All right, moving on to our next question. I've known for some time that IO ping results on a fresh install of FreeBSD, single disk ZFS type, are much better than on the Linux flavor that my employer prefers. I'm now planning to run Postgres with its ML extensions on FreeBSD and ZFS. Are there any cautionary statements that might be helpful? I'm doing this on my discretionary time, so there's no guarantee of interest on the part of my employer.
Yeah, I don't have any immediate insights there. Like in general, Postgres on FreeBSD is definitely very well supported and is likely to just work. On the ML side, it depends if you're needing specific support from the a specific graphics card or an NPU or something. But in general, that should just work.
Yeah, and I have no insight there.
I think my biggest insight is going to be I didn't hear much from this questioner about tuning considerations. And I would caution anybody against assuming that, well, just with all the defaults, I ran IO ping once on a Linux box and I ran it once on a ZFS box and I got a lower number over here. I wouldn't assume that told you everything that you need to know about the storage stack and where you're going to get the more performant result. And in particular, when we're talking about comparing a very specific storage workload like this, running Postgres with ML extensions, on a ZFS data set between two different operating systems, I would not expect the choice of operating system to have anywhere near as large an impact as how skillfully the tuning was done for all the, particularly record size. But, there's more above and beyond that. Do you want read ahead on a database? You probably don't, but you might, depending on how the queries tend to actually run on that database.
Right.
There are so many different things that you can tune to optimize performance for a specific workload, which is what you have here, that I would caution you to make sure that you know everything that you need to know about how to tune for your workload before you start getting worked up about which host operating system to run it on, because otherwise you're not going to come up with meaningful results.
Yeah, I think more importantly is going to be sort of what host operating system choice is more about. How does that fit into your environment overall? How's your administration in your your job will look like, and is it more inconvenient to be running this versus that? And I agree that you should be able to tune ZFS to be pretty comparable given the same hardware between the two OSs.
Yeah, my first instinct would be if you see a big difference between FreeBSD and Linux, you're probably not running the same version of ZFS on both, and that's why.
And that can go either way.
Mm-hmm. Yeah, if just one's newer than the other, then you're comparing apples to oranges at that point.
Yeah.
All right, I think we probably about wrung all the juice out of this one. So moving on, what do you feel is ZFS's most underappreciated feature?
So I'm a developer. So, the best feature of ZFS is the one I happen to be working on right now. That said, I'd say I'd go back to sort of the very origins of the ZFS concept and why and how we developed ZFS. As Jim was talking, I think before this webinar actually went live, when he first heard, that ZFS had a lot of cachet because it was, new and exciting, and it was gonna solve these problems. Mostly though, it was around reliability, and the reliability feature of ZFS is still its probably key feature that everyone should appreciate. Specifically, ZFS lays out its data. It's completely dynamic, so it's a pooled storage model, which again a huge feature of ZFS over a lot of its competitors at the time, is that its ability, though, to checksum all of its data from its block pointers. So when you lay out all the information in your ZFS pool, it forms what's called a self-describing Merkle tree, and you can actually reliably transport that in the open someplace else, as long as if you record, for example, the checksum at the top of the tree, which is the root block, and move that data to another site, move those disks to another site, and go through as many hands as you want. And on the other side, if you can compare that checksum and say it's the same checksum at the top, you know that your data has not been tampered with. Right? You cannot modify any data within a ZFS pool without ultimately changing that checksum at the top layer. And that, I think, is key. So the ability for ZFS to always be able to know when data is accurate, when it's been modified or not, or when it's corrupt or not, is I think a very, very key feature of ZFS. And people used to complain at us. It's like, well, I ran ZFS. I used to run, blah file system, and I never had a problem with my data corruption. And now I run ZFS, and it keeps telling me I have corrupt data here. And the answer was, yeah. The other file system couldn't tell you because it didn't notice it. We could always find it and say, you have corrupt data here, because this is in the days when people were not as likely to be running mirroring or RAID. So it was much more common to see this sort of problem. So I think that's a very key feature of ZFS.
Yeah, that's basically my answer as well. Although what I find the most interesting is specifically being able to use that checksum to know, for example, if you do have a mirror, which the two copies of the mirror differ for some reason. Now you can tell which one is the right one. Or even in a RAID Z, by going through the combinatorics, you can figure out which disk is the one that has the wrong information.
Yep.
And being able to blame somebody for the corruption means that you can, see that over time that, okay, this disk keeps having that problem, let's replace that disk.
Right.
Whereas if you just know some block was bad, but we don't know which disk it was, you can't really action it. But by being able to tell which copy is correct means that we can figure out which one is wrong, and then we can actually do something about it. And I find that to be just such a critical feature from both the operation side, but also just the management and administration side.
Yeah, and specifically in your comment about, like RAID Z, we used to call that self-healing in ZFS, because it would basically say, all right, I have a set of, I have my data spread across 8 drives with, 7 of them being data and 1 is parity, and I read it and I got a checksum error. I can now sort of, through this combinatorial process, figure out, okay, this is the block on drive 3 that is wrong, because I combined the other drives together and I got the right data, and I can actually rewrite the data on that block 3 and say, all right, problem solved. We no longer have a checksum error. I've returned you good data, and your data is more reliable again.
As
in particular,
at the time,
it means that those errors don't add up. If you do the scrub and you fix that error, when a different drive also does something to that same block, you can still reconstruct it because you fixed the previous error.
Which points to the importance of scrubbing frequently.
Yeah. I think it's kind of funny, Mark, hearing you talk about, as we described it at the time, self-healing, and like, I have to grin because as at the time, very much a ZFS outsider who was already starting to talk excitedly to people about this stuff, I was calling it automatic data healing, because like, what else would you call it? It's what it does. It heals the damage. And I already knew by that point in my career that I had discovered the hard way, what I think a lot of storage administrators have to find out the hard way, which is that RAID doesn't make your data it doesn't make your data's survivability increase. You're not reducing the chances of a failure by having a RAID array. You're increasing them because you have that many more things to break. And until you introduce something like, ZFS checksums that allow you to like quickly and easily say, okay, and this is the thing that broke. Like, no, it's really not usually as easy as like, oh, well, this is the drive that's bad and I pull that and replace that one. you encounter these things in the wild, and you learn that usually it's like, no, the entire array locked up and things are being corrupt and we don't know why.
Right.
And you're like Easter egging drives until you get rid of the bad one and hoping it is a drive and not a cable or a port on the controller or,
That reminds me of one. The other big thing is just the fact that ZFS is all software. That I could take the disks out of a machine that broke down, put them in a different machine, import the pool, and all my data works. I don't have to pray that I could get the same HBA with the same firmware to be able to import the array.
Right, right.
That has saved me many times.
And in fact, self-describing as well, where you didn't have to, it's like, boom, pool is there, it knows everything, it knows its contents.
It doesn't matter if I plug the disks in the same order or not.
Yes, and byte order agnostic, so you could actually move architectures. Now, at the time, that was more important because we were developing on SPARC hardware, but that was a key feature as well.
Okay, moving on. We're going to...
Jim, I just spotted a dRAID question, and since Mark is the expert there, maybe jump to that one.
We're going to get there, but we're going to do one other one first. It is very old school, and we're going to be able to answer it very quickly, but since it popped up, we're going to address it. Answering live from Nicholas. Can you talk about the need for ECC memory with ZFS? Is ECC a requirement or a nice to have? Allan, take it away.
That's mostly down to how much you like your data. So it's not any more of a requirement with ZFS as with any other file system. But if you're using ZFS, it's probably because you do like your data, and if you do like your data, if you can use ECC, you probably should. But there's nothing special about ZFS that means you have to have ECC.
Right, and on top of that, there's no magic in ZFS that makes it any better. That's any more reliable if you're not using ECC, right? Because you're now in the memory, and in the memory we make lots of assumptions that your memory, that when we grab a block out of the cache, that it's a good block. Now, that said, we do have some methods to do some checksumming of that data, and so we can do some validation there. But still, you can get data corruption. If you're going to get data corruption in memory, you're going to encounter problems.
Okay, and now this is a topic that has been done to death over the years, so we don't need to go into extreme detail here. Nicholas, if you or anybody else is still unconvinced, you don't think this short form answer was sufficient, please Google the phrase scrub of death, and that will lead you to my own exhaustive analysis of this topic from several years ago. But once you get to the end of it, the answers that we just gave you remain unchanged, which is that ECC is a great thing to have, and you should want it. In fact, you should be mad at Intel for segregating the market such that you don't already have it in every single device you ever use. With that said, no, you don't need it any more with ZFS than you do with anything else. So if you were happy with your personal desktop computer doing anything else without ECC RAM in it, you'll be just as happy with the same personal desktop computer running ZFS. All right. Now, moving on, we have the dRAID question. From Cedric. Hello, dRAID question. What are the drawbacks of using dRAID and let's say RAID Z3 plus 1 vDevs or RAID Z3 plus 2 vDevs to achieve 4 or 5 drive loss resiliency? Does dRAID have a performance penalty or other drawbacks compared to a regular RAID Z3 vDev?
So, the reason that we developed dRAID, we already had Z-RAID at the time, RAID Z. dRAID was a critical feature in environments where you have many drives that you're dealing with in your configurations. I was at the time when I was working on dRAID, and I was working for a HPC company, and it was critical that we had hundreds of hard drives making up our storage repository, and every time and drive loss was a fact of life. And any of you in the storage industry, in particular, who deal with large amounts of data in large configurations with large amounts of spinning rust, realize that drive loss is a common occurrence in these environments. And maintaining data reliability in these environments when you're using RAID is your replication mechanism for your data is critical. And so downtime between losing a drive and getting a replacement drive in there that's been rebuilt to regain your data redundancy is a critical factor to consider. And so dRAID's whole advantage is that it spreads, basically it takes the concept of RAID and spreads it across all the drives. So it's kind of like a pooled RAID concept. And so now your data is not just spread across 4 drives, say in this example, it's a 3+1 RAID. It's saying, all right, let's say I have 100 drives. I still have 3+1 data redundancy overall in my pool, but that data is now distributed across all 100 drives. So now if I lose a physical hard drive out of my configuration, I rebuild it from the data that is now distributed across the other 99 drives. And so I'm actually using 99 drives worth of bandwidth and data to rebuild out that drive. And I can reconstruct a drive in a fraction of the time it would take to rebuild it if I only had 3 other drives to rebuild that drive from. So that is the whole reason around the need and usefulness of dRAID. Does it offer, are there any gotchas in dRAID with respect to RAID Z?
The full stripe writes mean small
Yeah,
blocks?
yeah,
But
I think there are some, you get some more efficiencies off of RAID Z in terms of certain types of IO, because again, the way you distribute your data in a dRAID means you tend to be distributing your data across more drives in general, although that's not quite true, because you're still going to use three, if you're writing a stripe, it's still going to hit 3 drives or more randomly within the dRAID configuration. But yeah, I don't know. Allan, do you have some insight into where you think there's some gotchas in a dRAID configuration?
in general, no, other than the fact that, if you have especially a wider one in dRAID, you always write the whole stripe width, so very small blocks will be rounded up to a bigger number.
Yes,
But that's a big
actually
advantage. That's why it resilvers faster.
right. That's a good point. So yeah, so to Alan's point there, right, is yes, you always have to have a full stripe. That's true with in a dRAID configuration. So yes, if you have a wide stripe, that could mean that if you're writing small blocks, general rule of thumb kind of in the dRAID world is that your average block size, your stripe width that you should configure your dRAID should be approximately your average block size, so that when you write a block out there, your block is going to fit into the stripe. And so otherwise, if you write a lot of small block workload, all those blocks end up being padded out to the full stripe width, and you end up with a fair amount of overhead being spent on padding in that kind of configuration. So that's a good point.
And
Yeah,
I think
dRAID,
a lot of the
especially.
mitigation to that comes in, because dRAID is necessarily terrible at small block writes. For your small block writes, which includes all your metadata blocks, it would be a real good idea to have a special vDev available. And then the gotchas become your special needs to be at least as redundant as the dRAID is, because if you lose the special, you lose the whole pool. No ifs, ands, or buts. It's gone, period. So that doesn't mean a 3-way mirror if you've got RAID Z3 topology in your dRAID. It means a 4-way mirror on your special to maintain the same redundancy, because you need to be able to lose 3 of them to keep right on trucking the same way you could lose 3 drives and keep on trucking in your actual dRAID.
Yeah, and that's a good point. And we again in this HPC environment that I was working in at the time, that was again, we're looking very closely at using special vDevs for the metadata, and and sizing also is critical there to say, all right, there needs to be enough of that to handle the entire data in the pool. So you can't, if you throw in just a small amount of it, then you fill it up. It's like, okay, well, I'm not back to my old configuration. I'm going to be throwing that special data back into the base, the big pool. So so there's a lot of considerations when you talk about specials.
Yeah, we've
I
seen
think
that
another big
exactly happen
caution.
to customer was they added a metadata VDEV and saw the performance increase and loved it. So like, okay, we're going to enable the small blocks option and have all of our files that are 8K or less go to this as well. And the next day their special VDEV was full.
Yeah.
And they're like,
Yeah.
whoops.
I think another big caution that I would throw to people, we're talking about comparing dRAID with traditional RAID Z, is that if you're not already intimately familiar with the changes in performance that you get when you go from narrow RAID Z to wide RAID Z, like when you would actually choose to have 4 wide Z2 versus 6 wide Z2 versus 10 wide Z2 and what impact that will have. If you don't already have like a really solid grasp, like instantly in your head, you're like, I know when I would use each one of those things and why, and that it does make a big difference, you're not ready to design a dRAID pool yet. If you think that it is something that might work for you, you really should be reaching out to, a consultant like Klara that is, familiar with this kind of thing and can advise you on what your best options are, because dRAID can allow you to make some really, really suboptimal decisions at a very large scale, very rapidly. So try to avoid that. It is a great technology potentially, but these are just kind of the prerequisites before you start thinking about architecting your own solution. You need to thoroughly understand the topology of the more conventional solutions that came before it. All right, so let's move on to another live one from NewSpring. What's your favorite way to monitor your ZFS pools?
That's a good question. So I've worked at a variety of different companies with a variety of different sort of ZFS applications or use cases, and in my experience, there have been largely a kind of a roll your own approach to almost every company I've worked with in terms of monitoring and of their environments. And it has to do a lot, I think, with history and where these companies tend to come from and what they already had in place. And then they're adopting, say, whatever storage technology they're going to be utilizing. And they kind of fit it into their existing monitoring environment. So I don't have like something that says, this is the monitoring software that's been used across the board. I think it's more important to think about what is the right way to be monitoring your ZFS environment and what information you need to make sure that your environment is staying stable and correct. And as Jim pointed out earlier, making sure you're looking at the status of your pools, when you're getting errors, when you're getting, losing a drive, and addressing those things when they happen, as soon as they happen, and running scrubs regularly is the thing that needs to be considered, regardless of what monitoring software you're actually using to keep an eye on things.
Yeah, I would say my answer is mostly closely. So looking at it, whatever way an alerting system makes sense for you, but also if you can get metrics and have metrics over time, being able to say, okay, somebody reported ZFS seems slower than usual today. Let's look at some metrics and see what is different from yesterday when everything was fine. Is there more load on this? Is there more latency suddenly? Is one drive not erroring out yet, but slowing down and dragging the whole pool with it? And if we offline that drive, does the problem go away and we can fix it by swapping the hardware?
Right. Or that person just had too much coffee that day and things were exactly the same as they were the day before and they just thought it was slower.
Yep. Or did we fill up our special VDEV and now all the metadata writes are taking longer? Or, just being able to have some history to look at makes it much easier to tell what is different than yesterday.
Agreed.
I'll answer here as well that, being more specific, my favorite way to monitor my pools is using Nagios as the actual solution. And I actually use my own project, Sanoid, as a custom plugin for Nagios, because you can run Sanoid Monitor Health or Sanoid Monitor Snapshots, and it will return an exit code of 0, 1, or 2 for, OK, warn, or crit, just as Nagios demands for its plugins, as well as the human readable output to example, tell you, which of your data sets does not have enough snapshots to be in compliance with your Sanoid policy, et cetera, et cetera, et cetera. For those of you who, maybe you find Nagios a little bit too intimidating to get into right away, there are some cloud-based backend services available like healthchecks.io that you can curl a message to healthchecks.io using like your token and have that as sort of a poor person's monitoring system there. And you can, again, feed the same kind of command line checks directly into it. You could run a Sanoid -- monitor snapshots and pipe the results into a, curl to healthchecks.io. And you didn't have to set up like a full-on Nagios, but you're still kind of living like the big kids do with your custom written plugins and checking exactly the things that you want to check when you want to check them, and being able even to see some metrics over time on the back end when you open up a browser and go look at your healthchecks.io account and see what was reported and when, what does my history look like on this service. And basically, I think it's better to get like a good handle on this kind of thing and feel like, okay, I know what I want to check and how often I want to check it and the ways that I want to use that. Like once you get a good sense of that, then you can find the best tool for your own workflow. And it really doesn't matter as much. It's way more important for you to understand what you want to test, when and why, than to have somebody give you like the right answer as to like the program to use to test it with. If that makes sense.
Yeah. But yeah, I think a big thing is if you want someone else to monitor it for you or help you setting up your monitoring, then check out Klara's OpenZFS support subscription. And if you want to get help with picking the right hardware and deciding, should I use dRAID or not? Do I need metadata vDev? Which SSDs should I buy, etc. Our storage design implementation service is specifically designed to help with that.
Okay, backing up a little bit to Cedric again.
No, I think we're out of time.
Oh, are we out of time?
Yes.
Okay.
We hit an hour. So, but thank you everyone for coming, and we hope to see you next time.
Bye, everybody.
All right.